morning friends. Up to the 15.3 numerical of exercise we discuss. Now today we start our lesson from numerical of exercise 15.4. 15.4 numerical is given like to this. Use the formula V is equal to under root of gamma P upon rho. To explain why the speed of the sound in air is independent of pressure, increases with temperature and increases with humidity. Right? We have to discuss or we have to prove the velocity of a speed or the speed of a sound wave in a medium is independent of pressure. In spite of in this equation the pressure is present, but there is independent of pressure. Second, the speed of a sound wave in air medium is increased as the temperature of the air medium increases. And next, that is also depends on the humidity, increases with the humidity. So for that purpose, the given formula, the given equation is given equation of speed of the sound wave is V is equal to gamma P upon rho. When gamma is equal to ratio of two specific heat, Cp specific heat at constant pressure and Cv is the specific heat at constant volume. P is pressure, of air medium, rho is equal to density of an air. By taking the air as an ideal gas, so we can apply the equation of state for the ideal gas. Taking Na as an ideal gas, therefore, PV is equal to mu RT. PV is equal to mu RT. That is the equation of state for the ideal gas. But we know that mu is equal to M upon M0. Mu is the number of molecule. Where mu is equal to numbers of molecule in a given quantity of a medium. M is mass of an air, mass of an air, given air, and M0 is atomic mass or the molecular weight of an air. Of an air medium. Substitute here the mu is equal to M upon M0. Therefore, PV is equal to M upon M0 RD. Take the M in this side. Therefore, P into V upon M is equal to RT upon M0. But we know that mass upon volume, that is the density. But here, inverse of this, volume upon mass, so there is the 1 upon density. Therefore, our equation is P upon rho is equal to RT upon M0. RT upon M0. That is our equation number 2. That is our one. Right? Okay. Now in this equation, P upon rho quantity is constant because at constant temperature is constant. I is also the Hilbert constant, that is constant. M0, that is the molecular weight of an air, that is also a constant. So here, at constant temperature, P upon rho is constant. Therefore, from equation 1, V is independent of pressure. Because in this equation, gamma is already constant, P upon rho. Just we discussed P upon rho is constant because R and MCU are constant, and as we consider the temperature is constant, therefore the speed of a sound wave in a medium is independent of pressure, not depends on the pressure. Now, second part, B part, increase with the temperature. Increase with the temperature. Therefore, we know that V is equal to under root of gamma P upon rho. Substitute equation 2. Equation 2. Therefore, our equation becomes V is equal to gamma as it is. Instead of the P upon rho, RT upon M0. Therefore, V is directly proportional to the temperature. Therefore, the speed of the sound wave is increased with temperature. Thus, speed of a sound in air is increases with temperature. Now C portion. As the humidity increases, now we have to prove that increase with the humidity. As the humidity increases, therefore the density of the air medium decreases. From equation 1, V is proportional to the 1 upon under root of rho. 1 upon under root of rho. As humidity increases, the density of an air decreases. Thus, speed of a sound in air increases with humidity. Because as the humidity of the air medium increases, therefore the density of the air medium decreases. Now here we know that V proportional to the 1 upon under root of rho. Therefore rho decreases, V increases. How the rho decreases? As the humidity increases. Therefore, as the humidity increases, the speed of the sound in air medium also increases. Again, there is a very interesting numerical. Using the formula V is equal to gamma P upon rho to explain why the speed of the sound in air first is independent of pressure in spite of the pressure is present in the equation. Okay. Second, increase with temperature, and third, increase with humidity. Now the given equation V is equal to under root of gamma P upon rho, where the gamma is equal to ratio of Cp upon Cv. We learned about this ratio gamma in thermodynamics. Okay. Now P is the pressure of air and rho is the density of air medium. Taking an air as an ideal gas, therefore equation of state PV is equal to mu RT. Mu is quantity of a gas. That means that is the ratio of the mass of a given air to the molecular weight of air. That gives the quantity or the amount of air medium. Substitute here, therefore PV is equal to M upon M0 RT. Take the M in this side, therefore P into V upon M is equal to RT upon M0. Now M upon V is equal to density. that is the reciprocal of m upon v, that means the v upon m, that gives the 1 upon rho. Therefore, instead of the v upon m, we substitute the 1 upon rho. Therefore, p upon rho is equal to RT upon m0. Now, here at constant temperature, T is constant. So, I is constant, m0 is constant, therefore, p upon rho is constant. Therefore, from equation 1, v is equal to under root of gamma p upon rho. This part is constant. Gamma is also constant. Therefore, the speed of a sound is independent of pressure P. It not depends on pressure P. Because the P upon rho is constant at constant temperature. Now, second part, we want to prove that the increase with temperature. So, our equation is given V is equal to under root of gamma P upon rho. Just we obtain the equation of P upon rho. Substitute the value of P upon rho. Therefore, V is equal to under root of, instead of the P upon rho, RT upon M0. So, gamma R upon M0 are constant. Therefore, speed of a sound in air directly proportional to the square root of temperature. Thus, the speed of a sound in air is increased with temperature. Now, third, increase with humidity. As humidity increases, the density of an air decreases. Thus, the speed of a sound in air increases with the humidity. Because from this equation first, V is equal to under root of gamma P upon rho. So V is equal to 1 upon under root of gamma, 1 upon under root of rho. Therefore, V is inversely proportional to the square root of density. As the humidity increases, the density of an air decreases. Thus, the speed of a sound increases with humidity. Clear this? Okay. Now the next is 15.6. 15.5 is only we have to prove that this equation represents the wave equation or not. That is not important. Now, a wave emits the ultrasonic sound of 1000 kilohertz frequency. Frequency is given 1000 kilohertz. 1000 kilohertz. Therefore, that is the 1000 into 10 is to 3 kilohertz. That means the 10 is to 6 hertz. F is equal to. In A, if the sound meets a water surface, what is the wavelength of the reflected sound and transmitted sound? Speed of the sound in A medium is given VA is given 340 meter per second, and in water medium VW is given 1486 meter per second. Find the wavelength of reflected and transmitted sound wave in air medium and also the water medium. Now listen. That is the surface of the water. Now ultrasonic waves are traveling towards the surface of the water. There is the incident wave. Incident on the surface of the water. That is the air medium. So this wave perform the partially transmitted and partially reflected. So reflected wave is traveling in this direction again. That is the reflected wave. That is the incident wave. And that is the transmitted wave. So in short, the reflected wave travels in a medium, while the transmitted wave after the incidence travel in water medium. Right? So we can write like this, when the ultrasonic sound, or the when sound wave incident on a water surface that it partially reflected and partially transmitted. It partially reflected in a medium and partially transmitted in water medium. So in short, the reflected wave propagate in air medium, while the transmitted wave propagate in water medium. Therefore, the reflected wave traveling in air medium so its speed VA is equal to F lambda A. Therefore, lambda A is equal to VA upon F. VA upon F. VA is given 340 upon 10⁶. F is 10⁶ kilohertz because there is 1000 kilohertz. Here is therefore 340 into 10⁻⁶. Therefore, 3.4 into 10⁻⁴ meter per second. Sorry, there is the meter. There is the wavelength of reflected wave in a medium. While transmitted wave traveling in water medium, therefore its speed is VW is equal to F lambda W. Therefore, lambda W is equal to VW upon F. VW is given, that means the speed of a sound wave in water is given 1486 meter per second upon second inverse, that is the 10⁶. Therefore, 1486 into 10⁻⁶ is equal to 1.486 123 into 10⁻³ meter. -3 meter. That is the wavelength of a transmitted wave. So very easy, only we have to apply the equation of speed is equal to wavelength into frequency. Frequency of the wave in both medium remains same. Again, the question is that a bat emits the ultrasonic sound of 1000 kilohertz frequency in a medium. If the sound meets a water surface, what is the wavelength of the reflected wave, reflected sound and transmitted sound? The speed of sound in air medium is 340 meter per second, and in water the speed is given 1486 meter per second. This figure is only for your understanding what's happened. Here the sound wave is incident on the water surface, partially reflected, partially transmitted in the same medium. So when the sound wave incident on a water surface, it partially reflected, that means in air medium, and partially transmitted in water medium. The reflected wave traveling in air medium, so its speed is VA is equal to F lambda A. A stands for the air medium. Therefore, wavelength of reflected wave in air medium lambda A is equal to VA upon F. VA 340 upon F 10 is to 6. So 340 into 10 is to minus 6 or 3.4 into 10 is to minus 4 meter. While the transmitted wave traveling in water medium, its speed VW is equal to F lambda W. Therefore, lambda W is equal to VW upon F. Substitute the value of VW 1486 upon 10 is to 6 is equal to 1486 into 10 is to minus 6. It means 1.486 into 10 is to minus 3 meter. So thus we can find out the wavelength of the reflected wave and also the transmitted wave. Clear it?